Hey, welcome on a new tutorial. I stumbled upon some picture of a building called the Gallery of Cloaked in bricks. That is an actual building in the city of Tehran, and I thought this structure would be a very interesting case to bring in Houdini. So today, we will first set up a procedural brick wall, on which we will create some turbulence control, and we'll see how we can use the turbulence to accumulate over time and drive a full rotation thanks to the Orient attribute and Quaternion controls. If you don't understand what I just said, no worries, we're gonna see everything in detail right now. Let me just flag, if you are new to Houdini and wish to acquire some solid foundations, I wrote a blog article that includes a list of the most useful tutorials you can find from different artists and TDs, so adding the link in the description if you're interested. So let's start and create a grid. When we dive inside, we can change the orientation to XY plane, that would be the direction of a wall, and drop a delete node so that we get rid of the primitive and only keep the points. From there, I wanna make a test and just copy some box, see how it works. So, okay, right now it's looking pretty uniform, but as soon as we kind of stretch things, it's not conforming to the deformation. So one thing we wanna do is copy the parameter of the size X and pass that as a relative reference into the size X of the box. Then take the column parameter and let's divide that with what we had before into the size X. Now it's like stretching properly, which is cool. If you add more or less column, you got the size that's adapting. We should still need to do the same for the rows. So we just copy the size Y parameter, pass that here and divide that by the column input, by the row input. So we can play with the values and everything is like fitting properly. That's pretty cool. So if we look at my reference, there is a pattern going where every 5 lines we got like a smaller line that's probably static or something. So to do that, we're gonna need to drop for each number, and we're gonna create a group range. So group by range, we're gonna use the column parameter and feed that into the selection. This way it's like creating a selection of every line. If we tweak the offset, we now can get a line per selection per line and blast those points. Now the thing is, if we drop a group by range, we can turn that to point first and call it row. So we can make a selection every, let's say, 6 points. It's gonna select a point and gonna feed that in a group called row. So let's now create the metadata. What we wanna grab from this metadata is the iteration attribute, because thanks to this attribute we could actually feed it into the offset of the group range. So we use the detail expression to grab this iteration attribute. Default value is 0, and now we got 10 line because the number of iteration is 10. As soon as you change it, it's like creating that more or less line. So we want to match that with our original grid, so just copy the column parameter and pass it in the iteration. Now it's exactly the same number of points. So if we blast some points, we notice now that we get like some more like interesting pattern for bricks. They may be a bit thick right now, so let's decrease the size Z. Yeah, that's much better. It's much better. It's actually pretty interesting to add some randomness. I usually use point jitter to add some subtle variation, just on the Z-axis though, not X. Yep. Now you see that we got some randomness in the Z-axis. It's like looking more like a brick wall, I guess. Yep. Cool. Let's copy this copy node, and from there we're just gonna grab the column, sorry, the row, but yeah, that's looks like the right point template. So we could just merge those guys together and see the result. We could make more distinction by applying a color node and change the color. Yeah, so now we see clearly the orange is gonna be like the static brick, while the white will need some rotation thing going on. So we're gonna try to match that. Let's first reduce the scale in Y. So that's great, but we got a kind of gap going on between the white bricks and the orange brick, which means that we're gonna need to fix that. To do so, I usually like to create another group range where I select the middle of those rows. So I'm just copy the parameter of this first group range and feed it into the new one, the middle one, and same in the offset, but I divide it by 2. Yep. So now you see we got the points that's like in the middle, and if we blast some points and just keep the middle, we can now create some randomness in the color with an attribute wrangle, where we can say add color, please random the point position in Y. That's basically what we are saying there. Let's probably change the template in dark so that you can see better. Yeah. And now if I transfer this color onto the other points, we get a color per group of line. So that's great. Which means that we could create a partition based on those color. So group by color, don't forget to change entity to points. Right, so let's, yeah, we do get the new groups. If we try and just blast one, yeah, it did a good job, so that's great. Let's create an attribute called name based on this color. Yeah, that I think should work. Just don't forget to change class to points. We are dealing with points only. Let's move that a bit. And if we try a for each name primitive, we can, oh, okay, so again, piece element to points. And now it's gonna do a loop through every of those groups. So that's pretty amazing, right? If we transform and center the pivot to the middle of these elements, just by using $CEX, $CEY, $CEZ, now we can get a proper scaling on all those groups. So let's see, let's reduce the gap just by increasing the scale Y. Seems to work. You can also reduce the scale or increase the scale of the bricks. Now if we try to change the master grid, everything is like conforming properly and applying all the rules that we established already, so that's awesome. Yeah, let's just find like something we are happy with. That should do the job. Now we're gonna start digging into the animation of those. So if we try to rotate using a simple $F, you see we already got like an interesting animation. Now the problem is like they are all moving at the same speed and at the same time. Let's make this animation more interesting. We need first to create a noise that's gonna drive this rotation. So let's drop a point VOP. In there we're gonna use a turbulence, plug that into the color so we get a feedback. I use a fit range because I usually like to contrast things a bit more, like so. We can promote some interesting attributes, frequency, amplitude, attenuation, roughness. I like to make the frequency a bit more simple so that we just need to tweak one parameter. Yeah, it's just more convenient to find a scale. We can scale y, multiply scale y by 2 to get some more like stretching going on. Now we would need to animate this noise, so we're gonna need the offset to do that. Offset and the time. So we're gonna use a float2 vector, and basically the input where we plug the time is gonna create a vector on a certain axis. So if we set it in the first input, it's gonna drive it into the x axis, like that. So that's actually what we want. Yep, so that's cool, but it's like very uniform and everything. So we can create a parameter that we're gonna call speed and multiply that by the time. So it's 0 right now, so it's not gonna change anything, but if we set that to 0.1, it's like 10 times slower, which might be fine, but maybe faster. 0.5. So 0.5 would be twice slower. Alright, so that's a bit too uniform. We could actually create a turbulence, and we're gonna use it and multiply it by the position to create some distortion into the noise, the main noise. We just need to fit range this turbulence, like so, and the fit range value are gonna be set between something like 0.8, 1.2. The more you increase the maximum, the more distortion you're gonna get, which could be fine. So same deal, I'm copying my parameter frequency and reducing the roughness. Let's try that. Yeah, it's creating some interesting breakup, I guess. What we can do is copy the main frequency and paste it in the new turbulence frequency, but usually I kind of like to multiply it by 2 or something. I think we're getting some pretty cool breakups going on, so let's see. If we use the template point attributes, now the color is transferred to the bricks, so that's super cool. We're gonna create some parameter to control the offset though, so let's call this one offset y. You can also create another one for offset z. And basically for offset x, we're gonna need to add that after the multiplication over time. Yeah, let's not forget to plug it. And now we see that as we change those values, we are updating the position of the noise. Maybe you're gonna stop the animation, it's easier to see. Yep. Sounds about right. So here is the animation that's gonna drive the rotation of the bricks. So remember, we got the orange brick that are static, and we're gonna use point VOP. Inside, we are gonna set up the Orient attribute. To do that, we are using a Quaternion, and the Quaternion is basically using an angle and an axis. That's all you need. So we can create a angle parameter. Let's copy that in label. Right. One of the things though is Houdini is working in radians, not in degrees, so we need to convert whatever we are feeding there into a radiant. Can create another parameter called axis. This one's gonna be a vector though, like that. So the spinning axis is gonna be y, and let's try an angle of 360. Need to reset a couple of stuff, so we need to get rid of the $F that we had in the copy. We could actually apply a color to make it more interesting, and yeah, don't forget to reset the rotate y to 0 into the copy. So back in the point VOP, we need to export the Quaternion as an Orient attribute. What it's basically doing now is that we can change the angle, and it's rotating the point based on the y attribute. So that's exactly what we wanted. Great. So let's reorganize a little bit quickly. Apply some color where just to see where we have like the main controls. I'm gonna call that noise turbulence. The point VOP gonna be Orient attribute. Right, so if we make a test and try the $F like before, it's working great. Now what we can try is to use this noise to drive the rotation of our bricks. To do so, let's use, we can drop a multiply and drop a vector to float from the color that we have, and just pick any channel that we multiply by the angle. And now you see that the noise is basically driving the rotation. The problem is it's not completely spinning because the values are between 0 and 1, and once the noise is gone, it's back to 0, so it's like doing the revert animation. So as you can imagine, we're gonna need to fix that and have this brick rotating on 360 degrees. To do so, we're gonna need to get the noise accumulating through time. So on every frame we are keeping the values we have on the points, but it's like stacking up. The values have to stack up on every frame so that the values keep incrementing into the rotation. So we're gonna need like this kind of solver that I found on wiki, Houdini wiki. It's a very similar concept that we're gonna use. So just use a black color on the input, and the second input is basically the noise that we have. So I'm gonna plug that and disable the color so that we can see what's going on. So we got the previous frame in there, and we need the second input. So now we're just gonna need to drop a point VOP, plug the first input and second input, and inside we need to import some point attributes for the second, the color, so CD, and the first input as well. We could actually just use the first input there with color, add that together, and export that into the color. That actually should work. So now, as you can see, it's getting very wide because the values keep like stacking on top of each other at every frame. And if we put the Orient attribute at the proper position, now it's like spinning super fast. So there's something we may have forgot. Oh yeah, we need to get rid of the $F because now it's like driven by the accumulation of the noise. And now the angle is basically driving the speed. It's like a multiplayer. That's looking pretty cool. It's looking pretty cool. But as you can see, some bricks are very static and not moving at all. If we want to fix that, we just need to apply a minimum value to add on every frame. So we need this fit range at the end of the noise. And let's expose those parameters and apply the minimum value to something like 0.2 or so. So now you see that every point are getting affected, like not at the same speed, of course, because we got now a difference of 0.2 and 0.5 into the noise. So that's looking very cool, I think. And we got the 360 rotation going on. So that's pretty much matching the reference. Now, if we want to go ahead and try to get these windows, we're going to need, expand a bit the graph. So gonna start from here. We basically gonna replicate the same thing than the beginning with the for each and group by range. So I'm just gonna try quickly create a group by point and isolate the columns. So no, it's not the rows that we need to grab the column parameter and actually feed that into the selection. So I'm recreating the loop again. So gonna need the group range inside though. Okay, so I'm gonna need to call it column. That should sound familiar. Put a blast node and just isolate this column. The number of the iteration, I'm passing the column parameter in there so that we got the same number of points, and extracting the iteration metadata. So this time I'm creating an integer where I'm gonna grab the iteration details. So I'm doing a bit different this time because I'm gonna need to put that in into a point wrangle. So we can just put that in the offset and it's the same number of points than at the beginning of the loop. That's great. We can try to drop a blast and keep the... Oh yeah, but I forgot to create the group. So let's first create another group by range. And we can see that if we turn it to point, we're gonna select a row every 2 points, maybe every 4 points. Yeah, can offset it if we want to center it or something. So now if we try to blast the points and delete non-selected, we have the rows that we wanted. So to select some of the points in there, I'm gonna do things a bit different this time and use the modulo to drive how many points we want to skip. So I'm gonna create an attribute iteration, pass the relative reference of the detail that we had before. So we are feeding that into a iteration attribute. And in there, what we can do is create another attribute we're gonna call window. And this attribute's gonna be iteration modulo a custom parameter of a float that we're gonna just called modulo. Modulo is gonna be what's skipping the points every like 5 points in this case. So if we have a look at the spreadsheet, we do have some numbers that are gonna help us. How I like to set this up is using a switch with a null, and I'm converting the window attribute into a detail so that I can call it into the switch. So now if I add the detail expression, calling my attribute promote and my window attribute, that should be fine. So see, we now get a proper spacing. If we blast some points, we see that what's left, and when we change the modulo, we are changing the spacing between those points. So that's pretty cool. That's pretty cool. We could actually create an offset if we want to offset the spacing a certain amount of time. So to do that, I'm creating an expression with iteration plus a custom float that I call offset. I'm just gonna change this float into a integer instead and add a maximum of points. So now you see we can offset this window attribute along the points. So that's pretty cool. Now we can try to do a copy to point, and we're gonna use a box to feed as a primitive. Sweet. We're gonna need to make a group based on those box. So we can just create a group, plug the second input to the copy we just created, set the group to points, and call it window, for example, and change the bounding type to bounding object. So now whatever is inside the bounding box of our objects is going to be selected. And if we blast the window points, you see we got a hole. So I realize I may have not selected the best lines. Instead of using middle, I should have used row so that it's like matching what we have in the reference. Yeah, it looks closer. Yeah, it's looking better. We could just increase the size of the box a little bit so that it's like contained between couples of those static rows. Yeah, great. So that's the result. If we want, we can always go back to the master input and change the size, change anything, and everything's gonna update. So we can also change the number of columns, rows. Yep, so let's see. It's like magic. My point jitter is a bit too much though. Looking pretty sweet. One thing we could do is actually create a wire, so it doesn't make sense that they are like floating like that. There should be like a wire or something in them. So we could just go back to the beginning, drop a add node, and use a by group to create a primitive. We can group this primitive and merge it back into the main section. We're gonna call it like wire, but now it's like affecting a bit all points and stuff, so we're gonna need to blast it in there. So let's drop another blast, and we're just gonna wanna blast the wire so that we got all points back and everything. Yep, that's working. Let's see, same deal here, and yeah, everything is back to normal. what we can do is delete non-selected on an overblast and drop a poly wire. So now we can actually have some geometry. I'm gonna merge that with the rest, but let's first make a null so that we see a little bit better. Yep, actually I'm gonna make another merge to keep the copies together, and this guy in another merge. Yeah, that's better. So right now I'm dropping a boolean because as you can see, we may not want the wire to extend into the window, so I'm subtracting the wire to the box that are representing the window, and now it's working fine. If we decrease a bit the size in Y of the bricks, we can see a bit those wires. So that's pretty much it for today. This is the result of the animation once being in Blender. It's a very quick setup, didn't spend much time on it, so I may polish that later and do a tutorial on how to export the data in Blender and keep the instancing at some randomness, etc. So you know the drill, please like and subscribe, that would mean the world to me, and I'll see you in the next tutorial. In the meantime, stay awesome.